In this exercise, we have this group, right, with some arbitrary operation. And what we know about this group, what is peculiar about this group, is that the square of every element is the identity. And that happens for all the elements of the group, right? So we have to prove that if this is true, then the group is abelian. Okay, the first observation is, of course, that if x squared, which is just x times x, is equal to e, then, of course, x is its own inverse, because this is the definition of the inverse. The inverse is the element you have to multiply an element by in order to get the identity, right? So you have that. Now consider the product of two elements, x and y, and of course you know that for groups, the inverse of a product is the product of the inverses, but in reverse, like this here. But on the other hand, well, actually, the inverse of y is equal to y, right? And the inverse of x is equal to x. So actually, the inverse of xy is equal to yx. But on the other hand, we know that for every element, the inverse of an element is itself. So the inverse of xy has to be xy. So if these two things are equal, then the group has to be commutative or abelian.